Welcome back to Chem 101. In this video I'm trying a new style format here with this new whiteboard app that I have, and in this video I want to talk about how we name acids. Now the first set of acids that we want to name are those called binary acids. Now these binary atoms, they have only two atoms in them. And those two atoms are going to be hydrogen and some anion. So here are some examples of some binary acids. Now these binary acids will get the prefix hydro because of the hydrogen that they have, and then they'll get the ending ic. So for chlorine, this will turn into chloric. So chlorine just gets the ending chloric. There we go. So hydrochloric acid. So for HBr, we're going to get hydrobromic acid, and for HF, we'll have hydrofluoric acid. So that's how we name binary acids. We do have another type of acid, and these are called oxyacids. They're called oxyacids because they contain oxygens. And so let me show you a couple of those. Now we have H2SO4, let's see, H3SO4, H3PO4. I've got a few more that we can talk about. HClO, HClO2, HClO3, HClO4. There's actually 4 of these. And so what they have in common, obviously, is that they all have oxygens. Now, how would we go about naming these? So the rule for naming these is, well, first off, we need to know the name of the anion. So the anion in these cases is going to determine the name of each of these acids. So let's take H2SO4, for example. Let's take this one. Let's just look at how we would name that compound. Now H2SO4 has a few parts. It's got the hydrogens, and then it's got the sulfate. Now if you remember, sulfate, SO4, now SO4, it had a charge as an ion. It actually had a 2- charge, and hydrogen ion is going to have an H+. It's going to have a +1 charge, so we'd have H+. And so the name of this SO4 was actually sulfate. So if it ends in 8, then we're going to change it to ic. So for sulfate, that becomes, we take a little liberty here, sulfuric. It wouldn't be sulfic, but sulfuric, and each of the anions will have its own little adjustment to make, but the ending will be ic, and so sulfuric acid would be its name. All right. Well, what about a different anion? So let's look at a different anion, and let's look at the anion in the case where we had not H2SO4. But instead H2SO3. So it's very similar. Okay, so H2SO3 actually breaks into 2 hydrogen ions that are positively charged, and an SO3 2-, which, if you remember from our naming of polyatomic anions, is called sulfite. So the difference here is that instead of ending in 8, now it ends in ite, and so the ending won't be ic, it'll be us, and so it changes from ite to us, O-U-S. So sulfur would then be sulfurous acid. So sulfate would be sulfuric acid, and sulfite would be sulfurous acid. So let's now go back to some of those other acids, some of those other oxyacids, and look at how we would name those as well. Okay, so let's take a look at some of these. First off, let's identify the name of the anions in these cases. And what we're looking for here are the endings, ite, ate, because this tells us our endings for our acids. And remember, if it's ate, it goes to ic. If it's ite, it goes to us. Okay. So, chlorous acid, chloric acid, nitric acid, nitrous acid. Notice for phosphate, we couldn't just say phosphic, it becomes phosphoric. So sulfur and phosphor, some of these, like I said, have a little adjustments to make, but they all have that same ending pattern, phosphate, phosphoric acid. All right, let's look at a common problem students have when naming binary and oxyacids, when they think the names or when they think there's some sort of conflict. So let's take a look at an example of one that appears to be in conflict. Okay, so here are two acids that maybe the problem students have is that when they're asked to draw the formula for these two acids, they're unsure which to use. And one of these is a binary acid, and one of these is an oxy acid. Now the oxy acid, of course, has oxygen in it. The rule for binary acids is that we say hydro, and then we take the anion and add the ending ic to it. So for this top one, HCl, we would get the name hydrochloric acid. But for the oxy acid, the rule says that we don't say hydro. Remember, we don't say the word hydro. So here I think is where students get confused. Chlorate has the ate ending, so we would change the suffix to ic, so we would say chloric acid. The difference here being that the word hydro is not included. So same can be going when you're trying to name these from the formula. Chlorine and chlorate both would have their endings changed to ic, chloric. But keeping the rules straight and knowing that for binary acids are the only time that you actually say the word hydro, it should alleviate any kind of confusion between naming these two similarly named but clearly different acids. All right, I hope that was helpful. I hope this whiteboard presentation is a little easier to see than the whiteboard I was using. And in the next video, we'll continue with the final of our naming, and we'll name hydrates.